In this worked problem video, we're going to do a problem on intersecting planes. Let's set up the problem. Let's take two planes, pi1 and pi2. Here are the equations of the planes. From these equations, we can easily read off their respective normal vectors, n1 vec and n2 vec. Look at pi1, the coefficients are 1, 1, 1. Therefore, n1 vec, a normal vector, is I vec plus j vec plus k vec. Similarly, n2 vec is easily arrived at. These two planes will intersect. Draw two planes, one in purple, one in green. Look at the green plane. The green plane has a vector n1 vec corresponding with it. And as drawn, it should be normal to the green plane. Similarly, the n2 vec is drawn to represent a normal vector to the purple plane. These two planes are not parallel, therefore they will intersect. And here it's drawn. The line L is the line of intersection of the two planes. We want to come up with equations for the line L. All right, so here's our problem. Let's get working on the solution. If we want a line L, we need two things. We need a point on the line. Well, that point needs to be a point on the line L, the line of intersection. Therefore, it should satisfy both pi1 and pi2. An easy point to pick out is the origin. X equals 0, y equals 0, z equals 0. The origin is on the line of intersection. To come up with the line, we need two things. We have a point. The second thing that we need is the direction of the line. From the picture, we can see that we have the two vectors, n1 vec and n2 vec. And we know that the cross product of those two vectors is a vector orthogonal to each factor vector. Thus, it will point in the direction of L. So come up with our direction of L as n1 vec cross n2 vec. Nice. We're ready then to write down our equations of the line. We have three different versions. One version that we can write down is in parametric form. So to come up with the parametric equations, we'll need our two pieces of information. The point has coordinates x naught 0, y naught equal to 0, and z naught equal to 0. Pretty easy. Our second piece of information, y vector, the direction of the line. And that's giving our values for a, b, and c, the components of the direction of the line. Nice. Bringing that together, we come up with our parametric equations. A second way to describe a line is in a vector equation. Here we have r vec, which is going to depend on parameter t. If t is set equal to 0, this vector goes away, and it's simply r naught. For us, we can use r naught as the origin. That's just the 0 vector, so we can completely ignore it. And then t scaling v vec is t scaling this vector here. Thus, we come up with our vector equation. And a third form is symmetric equations, and here are the form of the symmetric equations. Again, we have for x naught, y naught, and z naught, all set equal to 0, and for a, b, and c, we use the components of our direction vector. Excellent.